This lesson demonstrates a very simple way to put a bunch of components in a window. All the example program does is place 4 buttons in a window so they can be seen and clicked. The Buttons 1 class is a frame, just like the frame classes we've been using in the previous example. It displays itself as a top-level window. Also, just like the previous frame classes we've been working with, it's given a single component to display in its window. That component, the one that's to be put on display, is created by and returned from the method named makePanel. The panel class is special in that it's both a component and a container. Because a panel is a component, it can be added to other containers for display. And because a panel is a container, other components can be added to it for display. Now, I know you can rewind this and play it again to be sure, but I want to say that again. This is important. A panel is a component, so it can be added to a container. And at the same time, a panel is a container, so other components can be added to it. And yes, it is possible to add a panel to a panel. To construct some complicated windows, it turns out to be a very good solution to add a bunch of sub-panels to a panel, then build up the whole layout one panel at a time. Don't worry, it's easier than it sounds. The 4 statements here create 4 buttons and add them all to the panel. The panel has a layout manager that will assume the task of sizing and positioning the buttons so they can be seen on the screen and used by the mouse. The new panel object containing all the buttons is returned to the caller. The new panel is then added to the frame for display. We have now constructed the window, but it isn't all laid out and organized just yet. The panel is just holding the list of buttons. It hasn't done anything yet because it doesn't know whether you're going to be adding more stuff to the list, so it's just sitting and waiting. What you need to do now is tell it to get organized and get ready to be displayed. And that's just what the call to the pack method of the frame class does. The pack method of the frame class calls methods in the panel class object that direct it to size itself. Then it calls methods to get that size. Well, now, for the panel to know how big it is, it has to ask its internal layout manager. In turn, the layout manager does its job by asking each of the buttons how big they are, and then, using this size information, comes up with an X and Y position for each button. With the buttons all positioned, the size information is then returned to the panel, which, in turn, returns the information to the frame. The frame then sizes itself to accommodate the size of the panel. But nothing has been displayed yet. Everybody has figured out where to display themselves, but nothing else happens. This method causes all the components to display. The frame window appears with all the buttons showing. Here, let me show you. The 4 buttons are on display. And they are button components, as you can see. They are clickable. They don't do anything else because we never did hook them up to anything, but they do display and act just like buttons. Now, the first time this window was displayed, the frame allowed the panel to determine the window size. But if we change the size of the window, the frame sends the new size information to the panel as a requirement. The panel passed the problem on to its layout manager, and something weird happened. This is because of the set of rules followed by the default layout manager and the panel object. We can change these rules by changing the layout manager, and we'll be doing that later on. But for now, I want to demonstrate the construction and use of some of the more interesting components.